Okay, good evening, Naganathan ji, Vidyadhar ji. So,
Good evening.
yeah. So, this session actually I have planned to discuss if you have any doubts regarding the past 12 weeks and also in any assignments, if you have any trouble solving those assignment questions. Uh, that is what I have planned for today's session. So, today's session will be a very brief one, rather a summary kind of a session. So, I'll be happy to take if you have any doubts regarding any concepts which we mostly which we tried solving in structural analysis one course. And maybe if you have something else apart from this course, if I'm able to answer to those questions, I'll be happy. Yeah.
You are having the problems, our assignments which were given to us.
Okay. I think I don't have. If you are right now, if you are able to, if you want to share your screen, you can share and you can just let me know.
How to share because I don't know much of computers.
Okay. I think maybe give me a second. I'll try. But what concept? The questions was on what concepts?
So I had major issue with the eighth week assignment.
Okay. Let me. I'm trying to sign in. Maybe it will take some time. But you can just explain me what kind of question was that?
Uh, it was on trust to
Okay.
find the redundant reaction.
Okay. 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 I think I have gone through some of your comments. I think maybe you even commented about that, right? I think you asked. Uh,
Yeah.
yeah, I think I've
I
gone through.
commented that it becomes unstable and the
Correct.
solution which is uploaded, he has not
Yeah.
worked out the reactions. So I am not able to understand how the reactions he has arrived.
Okay.
And means when we remove a redundant force and make a stable, means, what do you say, determinate.
Okay.
Uh, so how he has arrived at that reactions, I am not able to understand because it becomes unstable structure basically.
Oh, sure, sure. Uh, Others, if you have anything, meanwhile I'm trying to open that assignments. Abhishek, do you have any questions? Anyways, I think now I'm able to open. Yeah, I think I'm able to open this. Let me check if you are able to see the screen. You are able to see the screen, right?
Yeah.
Yeah, this is the assignment 8. So you're talking about this assignment. This one, right?
Yeah.
Yeah,
Fifth problem.
fifth. Okay. Okay. So calculate the horizontal reaction at support E of the following truss. Assume A is constant. Okay. So you have one as your DS, right? The static indeterminacy is one.
Yeah.
Yeah. So if you remove that, if you remove that hinge and you make it as a roller. Okay. If you So what's your question? So if you remove that hinge and you make it as a roller, then it is going to be an unstable system. That's what your question is. Is that what you?
And in the lectures it was clearly mentioned by sir that if you make it determinate, it should be a stable structure.
True. Yeah, I think even I feel the same thing. So see, in this, you're right that the reaction forces are actually concurrent. So if you see here, I think from support A, you have vertical reaction and there's an horizontal reaction coming in this way. And if you release this hinge and you make it as a roller support, you'll have a horizontal reaction here. So vertical reaction from A and horizontal reaction from E are concurrent. So they are actually like they're going to meet at some point, intersecting at one point. So yeah, you're right. Actually, it is going to be an unstable structure. Okay. Yeah,
So
but still,
further,
but yeah, yeah. Go ahead.
he has given the reactions and all, but I'm not able to understand how he got it.
Okay. For that, I need. See, anyways, I that is actually, I think maybe there is definitely an issue with solving this problem. Even I feel that the reactions are concurrent, and then I think when you make the structure as a redundant structure, I mean, make the structure as a determinate structure, then it should definitely be a stable structure. But I think somehow to this question, I think he's able to solve the support reactions. So,
Yeah.
so
Yes,
the
but he
support,
has assumed that hinge has he has taken that reaction at E. He has
yeah,
taken the hinge inverted.
hinge inverted. Okay, but even that, see,
So,
even if you take hinge inverted, the forces are going to be the forces are going to be concurrent, right? Even in that
yeah,
case. Okay. Yeah, even I agree. I agree to your argument. Definitely, I think it is. It is an indeterminate structure. Once you, it is not a. Um, it is not a what do you call um, stable structure. That is for sure.
correct.
Yeah, yeah. But if you take that as an option, right, you are able to get it right. You are able to solve the solve for the reactions, right?
No, I didn't try it further
Okay.
because reactions I'm not able to get once it becomes unstable.
Okay. So in that case,
Also,
you'll only in that case you'll only have let us say I'll take reaction at E. Shall I'll share another screen. Like I need to share my writing pad here.
yeah,
Let me just solve it. So let us just assume that it is fine, and let us solve what we'll see what we are going to get it. So is my another screen visible? No, right? My writing,
no, it's not visible.
it's not. Yeah, okay. Yeah, let me just write down the question. Now you're able to see my screen, right? You're able to see my.
Yeah, yeah,
Okay. So this is the question, and you have 50 kilonewton acting here. And what was given? The lens are given 3, 4, and 4. Okay. So for suppose I'll make this as a hinge one. So let me take this. Let us say this is A and this is B. Like for just time being. So if you take this, okay. You let us moment at A. Let us take 0 summation of the moments. So you have 50 times 3 acting clockwise, and you'll have a reaction force here. Let us suppose it is going in this direction leftwards. So that will be generating an anti-clockwise moment, right? So this is, I'll take it as horizontal B, horizontal B times 8, that is 0. So HB is 150 divided by 8. This is my HB. So HA should be 150 divided by 8 here, and vertical reaction will be 550. Yeah, yeah, we are able to solve it, right, with the allergy.
Mm,
We are able to solve, but conceptually, you're. I think that is true that it is going to be a unstable structure. That is for sure. What
no,
usually happens is, yeah, when you remove it, right, it is going to roll down like this, and this is a hinge, right, so it will allow a lot of larger deformations, so it is
but
going
I
to come
think
like.
after arriving at the forces also that at the end it was not getting satisfied. The reaction which was
Okay, okay, is
getting
it?
after solving, that was
Okay,
from my side. I don't know. He has given the solution, but that also I was not able to get it rightly.
okay, maybe I need to go through the solution. Can you just wait for a minute? I'll just go through the solution once. I mean, I'll share the solution. Let me just share the solution. NPTEL solution for week 8, right? Week 8.
Yeah, yeah.
So the solutions are shared in. Is it in the course thing, or is it like
No, it's in the course.
it's in the course only, right? Coursework.
Yeah, yeah.
Okay, week back it assignment solution. Yeah. Okay, let me check this. I think I need to share the screen again. Let me share. Oh, or else are you able to see the screen? Other one? Vidyaji, are you able to see the?
Yeah,
Are you able to see my screen? Other one?
it's too small.
Not this one. I mean, now you can see my assignment solutions, right?
Yeah.
Okay, okay, fine. Okay, in this case, okay, okay. That's what I see. I don't think there is any see, even in this case, if you see, you have a vertical, you will have a vertical reaction at E, and you have both vertical and horizontal, but this horizontal and vertical will be concurrent. So in that case, yeah, that is definitely going to be an unstable one. But it is pretty straightforward. Like, see, if it is 50, right? So okay, okay, okay. Then how did he get this as 0? That is the question. So if it is 50, you should have 50 in this direction. So you don't have any forces in A. You are able to follow Vidyadarji?
Yeah, yeah,
See,
yeah.
if it is 50 here, right? So you should have opposite direction. You should have a force at E in opposite direction. That is, which is acting upwards. So to balance this force, to balance a moment at A as 0. So that means 50-50, there is no balanced force. So the forces at A is 0 in this case. So if the forces at A is 0, AD will be 0, AB will be 0, and DB will be 0. If this is 0, then you will have 50 tension, and this is also 15 tension. Yeah, that is kind of, that should be fine actually. But yeah, when the point comes out to stability issue, I think that, yeah, I think that has to be did yeah, I think that has to be a stable section. Yeah, before, even if you, even after you convert, that has to be a stable section in question. You are asking about this, right? Like, is this the question? I think not this one. You said this. Yeah. Now for the assignment. Yeah, yeah. I think he also mentioned this thing, right? I didn't notice this. He also mentioned it is stable, but yeah, for the solving purpose, I think you can just go ahead and solve. I don't think these kind of questions will be asked in the end exam. Maybe I think you're not no need to worry about it.
Hopefully.
No, no, that is for sure, because this. Uh, yeah, end exam will be more. It will be cross checking twice or thrice.
Okay.
Yeah, yeah. Anything else you want to discuss, or you have any
Yeah, one more problem of 11th week.
11th week? Sure. Let me just open that. 11th week.
Eighth problem.
Yeah. 11th is
On moment
moment
distribution.
distribution. Yeah. Eighth one. Okay. What will be the distribution factor for segment BC? So segment BC. So BA we have 3A by
Yeah,
L.
that I arrived. But how to solve a joint with three members?
Yeah. See, it is again.
Normally,
Sure, sure. Yeah, I understand. I understand. So in this, what we need to do is, I'll just I
basically
think.
ninth problem, based on the same question. Yes.
Okay, calculate the vertical reaction and for this you need to solve everything. Okay, okay, okay. Yeah. Now, see what he's trying to do is you have a vertical member, sorry, you have a horizontal member, and just let me first copy down the question. Horizontal member, you have a. I think there is someone who just joined. So you have a vertical horizontal member, and you have a roller support here. So I'm not worried about it. This is 15. This is 12, and height is 12. This is 8. Let us take it as it is. So this is again similar to what we were discussing earlier also. So this support, right, this is A, B, C. Let me take this is D and E. So at this support, I mean at joint B, we have three members, which is AB, BC, and BE. Okay. So we have again distribution factors. We'll be writing down the distribution factors, right? So the total stiffness over there is K total is this is a hinge support. This is a hinge support. This is again a fixed support, right? So we have 40I by L plus 40I by L plus uh, 80I by L, right? So once we have that, that is 40I by L plus 40I by L plus 3I by L. Okay. So we have something like this. So this divided by this is my K total for each distribution. Let us say for AB it is 3I by KT, 3I by L by KT, and for BC it is 4EI by L by KT. For BE it is again 4EI by L by KT. So that is how you'll be doing, and only the okay, yeah, yeah. So what's your question?
No, at the joint there are three members. So how the actual distribution of moments takes place?
So what happens is that right now we have this moment here, and we this moment and this moment, right? Initially we'll be finding
Yeah,
AFEM,
that is
yeah,
fixed and moment.
fixed end moments. So you first maybe you write down as this. Let us say this is x1, x2, and let me also write for x3. So now the concept is x1 plus x2 plus x3 should be zero, right? At the end, the moments, the sum of the moments at that, like uh, moment about BA plus moment BC plus moment BE, sum should be zero. So first you do x1 plus x2 plus x3, you'll get some value because it will not be zero because it is not yet we did not equilibrate it, right? The equilibrium did not exist yet. It is just our first iteration. So maybe you'll get some value x. So you will divide this x error. So we need minus x to actually apply, so that we'll have joint moment as 0. So this minus x, you'll be dividing it with the weightage of the distribution factors. So that minus x will be, so let us say distribution factor of AB is, let us say d1. So you'll have minus x into d1 here, minus x into d2 here, minus x into d3. You need to understand that d1 plus d2 plus d3 is equal to 1. Distribution factors at the joint should be 1. So this is again a similar process. You'll be distributing it equally, by the weightage of the distribution factors at that joint. So even if you have a four members, let us say something like this. If you have four member, so at this joint you'll be distributing you'll take four different members and you'll be distributing the moment accordingly. You'll take the sum of the moments there. You'll find out the error. The error is nothing but the sum of the moments should be 0, but you have something excess or you have something less. So you'll try to apply a negative thing. So you want to negate it, so that if it is excess, you will deduct it. If it is less, then you will add it. So that you will be distributing among each member which is joining the joint. Which is coming and meeting at the joint. So that is how you distribute it, and then it is again the similar process. So at the end, what you need to check is whether AB plus BC plus BE is going to be 0 or not. That is the main thing at the end. Once you get that, if that is going to be 0, that means you are right. Your progression of your problem is right.
So only one in one distribution, I think they will get the answer for the
Okay,
result.
yeah. See, that is how I think it should, because if it is a complete what do you call full descriptive exam, then I think you will have this for like 10 marks or 15-20 marks, some 15-20 points. So this is like a multiple choice, right? I think you need to complete within some set time also. So I think you'll have mostly such kind of questions. Maybe you'll get the answer in one or two iterations. And even if you're not getting, maybe you can just check your answers whether it is tallying with the multiple options which is given
Yeah,
or not, rather than nearest, rather than again going for a lot of iterations and killing your time. This is again multiple, answering multiple choice question perspective. Yeah. And anything else?
actually in eighth
Eighth week.
it's the eighth week. Yeah, eighth week. Even that eighth problem.
Eighth problem. Okay, let me. Okay. To solve a problem using the method of consistent deformations, we need to solve the equations d1l by d1l d2l plus so and so x1 x2 equal to 0. Here, as per our problem given in question number 7. Question number 7. Okay. D1L, D2L are assumed as displacements along members AD and member AE respectively due to external loads after removing the redundant in the primary structure. F is the flexibility coefficient, X is the redundant force. Now calculate the flexibility matrix F11, F12, F2. Okay. So D1 and D2, right? So D1 and D2, plane structure, pin jointed. Everything is a pin jointed. It's a plane structure. Okay. So yeah, what's your question?
Uh, it was quite tough, but after going through the solution, I am able to understand to some extent.
Okay, AD and AE.
There was,
So D1L are actually displacements along the members AD and AE. That's what he was saying. AD and AE along it. Okay. Due to external loads after removing the redundant in the primary structure. So F is the flexibility matrix, flexibility coefficient. X is the redundant force. Okay, and so now calculate. So see again. Uh, Whenever you are asked to find out the any matrix like stiffness matrix or flexibility matrix, right? So the main concept behind it is when you are trying to find let us say you are trying to find f11. What does it mean? That f11 means the displacement along the direction one when you are actually giving a unit load of 1 kilonewton or 1 unit along that direction in the direction of 1. Okay, so in this 1 and 2 resembles AD and AE. Actually AD in the direction of AD and AE is actually in that direction, that is 45 degrees to the horizontal. So when you are trying to find f11, that means you need to restrain all the other forces. They'll be there. They'll The other forces are zero. Not zero. Actually, you are restricting the what do you call it? Restricting the movement of those forces. Okay, it is not moving. So once f11, that means you apply unit load in the direction of AD. Okay, that is in this direction. You apply unit load in this direction, and you find out what is the because of that what is the force in AD directly. One thing, and second is that what is the uh, force in AE. Sorry, it's not force. It's not force. It's when you apply unit load and you find unit displacement because of that. You are able to follow. So
Yeah,
you
yeah.
up yeah. See, in this direction you apply unit load, unit force. Okay, and you find out what is the displacement of that unit, that is AD, how much it has displaced. So that is going to be f11. And similarly, in this direction, if you are applying a unit load in this direction, that is 1 kilonewton in AD direction, what is the displacement in AE? AE is also going to stretch in this direction, right? So in that direction, how much is it going to stretch? So that is what f1, that is what f21 means. So what is f22? F22 is you apply unit load in AE direction and you find out how much A is going to stretch because of that, and you apply unit force in AE direction, and you find out how much AD is going to stretch. So that is going to be f22 and f21. Yeah. So this is again you need to just fix something, and then you need to find out. So this is it is almost a linear problem. Actually, it is you need to just find out what are the displacements in that area, how much stretching is, how much stretching is happening. I'll just go through solution also. We'll just see because again if I try solving now, I think it will take a lot of time. So what was this? Yeah, this one. So in question, you, is this question 8, right? We are talking about question 8.
Yeah, yeah, yeah.
Yeah, question 8. So consider member AB and are redundant. We have to find out the member forces. So AD and this is the redundants. So remove both the redundants. Find out member forces under external load. This is this is the process which we usually do. That is fine. So case 1. Now uh, AD and AE are actually. Oh, this is not the. Okay, I think he has completely the complete solution is available. Anyways, let us first. This is our the this is a determinate one. So this we are trying to remove one, and we are applying a unit force or the unit load. In this, he is applying a uh, what do you call the horizontal load, or sorry, the compressive load here. Similarly, in the second case, he's applying a compressive load but in AE direction. So this is my F22 or the second degree of freedom direction, and this is my first degree of freedom direction. So now D1L, okay, D1L is like D unit load or D1 in this direction, that is one direction, is nothing but summation of all so and so Ni and Li. Ni is nothing but this thing. What is going to happen in my determinate analysis or determinate beam. So sorry, determinate structure multiplied by Nij. So we know these are because of your unit load in this direction AD. So the similarly D12 and also F12 and F22 is that is just you need to interchange that. So you can see here AB, AC, AD, AE are the members. NI will not have any redundant members. So in NI you only have AB and AC. So this is direct solution. You have 100 external forces which are acting. So 0 and 0. So N1I. Okay, N1I is this one. So you can see N1I. So because of in this direction, what is happening in AB, what is happening in AC, what is happening in AD, and what is happening in AE. Okay, so you can see this 0. He has already found this uh, 0.707 in AB, 0.1.366. This will be 1 because you are applying force in the direction of AD. So if you see here, it is 1. This is so and so. Here we don't have any force in that because that member we have already there's no member in that, right in our N1I system. So N2I is again you have only 2 but you don't have 1. That is you have only AE but you don't have AD. So in that case you again find out the forces. So you have this 1 kilonewton because of this force 1 kilonewton. You have 1 kilonewton acting in this direction. You have square root of 2. I think so. This is one root 2. So 1.414 acting in this direction, which is compressive. So you will just write down this. Now you need to again jumble all these things. So if you want to find L1, N1, Ni, Nij, this is you need to just multiply these things and divide it by AE. So AE is constant, so we are not bothered about it. When it comes to Li, Ni, 2ij, this is you'll be doing this. But for us, they have asked what is F11, F12, right? So when you have F11, that means this is my F11 in this direction. If you apply in this direction, what is the load? What is the displacements in each step? So in each step, you'll have 3.53, 9.93, so and so. You'll write down the sum, and even this Li times N2I whole square. N2I whole square is nothing but this is F22 term. So in that F22 you have this thing F12. So this is F12 term. So you have this. So you need to be. I think you by now. I think you know that F12 is equal to F21. So it is a symmetric matrix. Flexibility matrix is a symmetric matrix. So that is how you have found 18.634 and this. Shall I explain it again or shall I? Is it fine? You
No,
are able
no,
to.
I got it. I
Yeah, yeah.
will solve it and I will try.
Yeah, it's better you solve this. So this is again it's very straightforward. Whenever we are solving an indeterminate structure, first we'll try to break down it into determinate and then into and then again we'll break down it into complete determinate structures, but one determinate structure will be with the external loads, and the other one will be the same determinate structure with the loads as with the loads as a redundant forces. Okay, so in this the redundant force is AD, and in this the redundant force is AE. At the end, again, what we are trying to do is we are just trying to match up. We are trying to again do the compatibility equations to find out the final forces. Yeah. But actually, in this he mentioned it as a plane structure, pin jointed. Yeah, that sounds good. Okay, that is fine. If it is not a pin jointed, then I think we'll have a lot of speculations on it.
One more is assignment 5, problem number 8.
Assignment 5, problem number 8. Just a second. Assignment 5. Okay. The bending moment diagram of the beam is shown in the figure below. Which one of the options might be the correct supports and correct might be the correct supports and loadings? Actually, bending moment is given, and he's asking for okay.
So answer is given as A actually, but I don't think it is A. A would have given the hogging moment at A, joint A.
Okay.
But
Let
it
me
is
again
shown that
let us just go from the theory. Okay, let us just go from the theory. So so D part is quite that is going to be the correct. There's no doubt about DE part, because DE we have a linear loading. Again, we have a quadratic kind of an equation there. It's not a quadratic. I think it's kind of a
yeah.
cubic kind of a equation, DE part, bending moment diagram. So that maybe that can be one of the kind of a loading which we may expect. And at E there is obviously there is no moment. That means it should be unhinged. So yeah, that part is uh, fine. That is okay. Uh, and even CD part there should not be any loading, because when if there is no loading, it just let us say if there is in this part you have some reaction force here, and the moment is always this reaction force plus this is always constant, it only varies with x. So it is again kind of y is equal to mx plus c kind of a plot. So this is linear. That is true. That is correct. And in BC part, if you see at BC part, there is a change in slope, right? There is a change in slope. That means there should be some load which is coming at C, which is kind of negating it. Like, let us say if there is no load at C, in BD part, as you go from D to B, the the slope there's no change in slope, because it is always this forces into this distance plus support reaction at D plus this distance. So that is going to be always with the same slope. That is like y is equal to mx plus c. But after this c, we it happened to have a different slope BC. So that means there should be one point load which is coming at C. That is quite that is okay. That is fine. Now at B it is a hinge. Why do we say it's a hinge? The moment is zero there. Okay. Mm, yeah, the moment is zero there. If the moment about that point is zero, yeah, the moment is zero. So that see the at B, if there is a moment, okay. Mm, if we don't have a hinge there, if he doesn't have a hinge there, how is it? See, I think the slope. Okay, okay. So now consider the slopes here. Like you have the slope. See, the reason why actually he's giving this kind of a thing, right? It is I mean, the question here, the person who's asking this one. So he's trying to convey that the slope at B, the slope of the bending moment at B is same before and after. So if that is the case, the shear force is same before and after. Okay, the slope is zero. That is fine. So it should be a hinge. Okay. See
No,
again, this.
actually, I think there's some confusion at joint A because joint A is having a hogging moment. So because the answer given is A, so bending moment diagram at A should have been below the horizontal line, no?
True, true.
It
No,
should
I'm
have,
just trying to understand the hinge part also. So if you see, this is a straight line. Maybe they should. Yeah, maybe if we have some. Okay, maybe I think this is mentioned because I think just to say that the slopes are equal in this part, AB and BC part, and this is a non-linear one. So that actually gives us the linear, the UDL. That is fine. Now coming to B, coming to A. So yeah, this can be the possible thing. See, if you have this as a hogging moment, right? So usually it is decreasing. Maybe because of this is actually you have a negating effect, and at B it is going to be zero. So yes, maybe this is hogging. Okay, this part is hogging and this is sagging.
Your screen, can you maximize it because I'm not able to
Oh,
see
is
it
it
properly.
okay? Okay, okay.
Your other screen is shared.
Okay, shall I? Not you are able to
Writing
see.
pad is shared.
Okay, but the other one is not. You're not able to see the.
It, it is it's quite small inside.
Okay, okay. Like okay, let me just stop the sharing from that, and then now you are able to see this.
Not yet.
Maybe just a second. Now, any?
No.
It is still very small. It is like you are able to.
Yeah, yeah.
Fine. Let me
It's coming
just
on the side.
let me just stop and share again. I hope you can see the screen now clearly.
Yeah, yeah, yeah.
Yeah. So yeah, possible. This is possible because see Vidyadarji, like right here, let us say I have a hogging moment. Okay, let us have a hogging moment here. Just for sake of understanding, you have this UDL, which is a gravity load, which is acting downwards, right? That means it will give a sagging. This gives a sagging effect. So because of this effect, hogging and sagging is getting negated. How is it? That is why it is actually going down like this. So the bending moment at this point is going down like this, and when it comes to B, the movements are going to be zero because it is the okay.
No, but if
For,
there
for,
is a
for, for
hogging moment already at joint A,
okay,
in the beam, there will be some point where it is changing from hogging to sagging. No?
that's what. So that is B. That is going to be B.
No,
Okay.
but at A itself, they are indicated as sagging moment and taken up because if you see the point D,
No, no. See, up
at
and down
point
again. Up and down is actually again. It's we uh, up and down. I think. See, if they are taking it as up as a sagging moment, right? Okay, you are saying. Okay, let us just put that aside. Let us just go from the basics. Let us say A is hogging. Let us say A is hogging. Okay. So once if A is hogging, and if they are mentioning A as a hogging, and if they are trying to um, show the bending moment diagram upwards as hogging. Let us say that. Let us just suppose for time being, and it is actually going down because you have a negating effect coming from the UDLs. So
yeah,
the bending moment is given as zero. Okay, that's all right. Maybe that is. Let us say the bending moment is zero. That bending moment is zero is only possible either at a hinge or where the curvature is changing in place, like point of counterflexure. So let us just assume that at B the bending moment is getting zero. Let us not come to the conclusion yet about that. Now, after this, you have a uh, okay upwards. If it is hogging, then we need to then we'll have downwards. Then that should be a sagging moment. But in this area, you have a sagging bending moment. So this should be sagging, right? So
yeah.
this entire part is sagging. Also at D, uh, see at D actually it should be
It should have
yeah
crossed the horizontal line.
yeah it should have crossed the horizontal line because at D there is going to be a hogging moment at D. Okay, But this part I'm pretty sure this is going to be a. So I mean this whatever we will have a hogging. See, it cannot be sagging. That is for sure. Because if it is sagging, right? I'll let me share. Let me share my another screen. Just I need to. I want to draw something. See, now you are able to see my new screen, right?
Yeah,
Other one.
writing better.
Okay. Oh, I think my pencil. What about the question? Are you able to see the question?
Yeah, I'm having the question paper over here.
Oh, okay, okay, fine. Okay, fine. So let me just write down the question once again. Give me a minute. I think my pencil is getting charged. Just give me a minute.
Yeah, yeah, no issues.
Yeah. So what I'm trying to say is, let us say I have this is my A. So this is what he's trying to. I mean, they're trying to show in the question. So if you think that if this is a sagging moment, or if you think that this is sagging moment, no, yeah, if it is yeah, if you think that it's a sagging moment, then in that case we have this UDL. So let us say it's a sagging moment, right? So let us say it is sagging. So we have sagging, and also because of this you have a hogging bending moment. So yeah, that they're showing it as a sagging, and then they're giving it as a, yeah. Now I get your point actually. So let us just take some numbers and just work out what's wrong in that. So let us say this is 10 kilonewton per meter, and I'm taking this as a hogging moment. Let me take it as, let us say some hogging moment as maybe 10 kilonewton meter. I'll just take this as a hinge, right? Let me take it as a this thing. So length, let us say 10. Now what happens? You have uh, yeah, you have a hogging moment. Because of this hogging moment you have, this is hogging, and because of that hogging, and then this is 0 plus. you'll have something like this. This is hogging and this is sagging. Yeah, when you actually add them, right, you'll be getting something like this. Whether you are able to understand.
Yeah, yeah, yeah.
So, so what I'm trying to tell is, let us say you have a simply supported beam. You have a hogging moment here. Plus you have some UDL coming like this. So because of this hogging moment, you'll have something like a triangular variation. Plus, because of this UDL, you'll have a sagging bending moment, which is again parabolic. Like as we know, it is a parabolic. WL square by 8 will be the I mean, at the minimum, we'll have that WL square by 8. So at this point, it is zero. At this point, you just add both of them to find to get uh, the final one. So this is something like this. So at each point, it is going to decrease, 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 decrease,
But
and
then
then
it should have been reverse parabola.
why do you say so?
Oh,
See, this is hogging, right? So, do you like? You're sure that this is going to be hogging, right? If this is hogging, I'm trying to um, I'm trying to draw this upwards. Okay, let me just make it clear that hogging. I'm trying to draw it upwards. So this is hogging. This is because of this, and because of UDL, we'll have a sagging, right? Which is actually downwards, right? The bending moment is always the bending moment is sagging.
hmm.
So if this is sagging, this is downwards, and this is upwards. So in my first step, that is going to be something like this, or it's better we'll use some. I think it's now. Let us use some numericals and then solve this. By that, I think this is 10 kilonewton meter. Let me say this is 5 meters, and I have a hogging bending moment of 10 kilonewton meter. So now let us solve support reactions. So the support reactions will be, let me take moment at B0, delta sigma B at 0. For that, I have minus 10 plus vertical reaction at A times phi uh, minus 10 times 5 times 2.5. And how much is this going to be? 5 VA is 25 phi is 20, 125, 135, and VA is going to be 27, 27 kilonewtons. So 10 phi is 50, and this should be 23 kilonewtons. Okay, now let me draw bending moment diagram. I'll take some section X. Okay, at section X, MX is going to be uh, this is hogging. So I have a minus 10. Sagging is positive. I'll take positive. 27 times X minus 10 into X into X by 2. So this is 5. So 27x minus 5x square minus 10. Okay. So this is again a parabolic curve. You take any, maybe we can take any point. Let us say at x equal to 1. What is it going to be? 27 minus 5 minus 10. That is how much is this? 27 minus 5 minus 10 is 15. That is 12 kilonewton meter. Yeah. And at 5, when you take 20 at distance 5, that is going to be 0, because at moment at B is 0. So okay, that is going to be a sagging moment or hogging moment. Maybe What if your moment, this is 100, let us say this is 100, even in that case you'll have the same thing. This is 100, uh, this is going to be 125 plus 90, right? This is 225. 225 by 10 is 225 by 5, 40, 45. This is 45. Okay, maybe in this case it will be something different. Oh, sorry, this is 5. So again, in this case, 45x minus 100 minus 5x squared. So you take it to 1 point, mx is equal to, at x equal to 1, it is minus 100 minus 5. Yeah, here it is going to be negative. That means it is going to be hogging. Okay. Again, yeah, this is kind of a tricky, not tricky or not tough, but yeah. See, Vidya, you are able to appreciate this, right? Like what I'm trying to do is initially I've taken a very less hogging moment here.
No.
Then, like you said, I'm getting I'm getting a sagging moment in within my beams. Like everything in my beams are sagging. But if I take my hogging moments at A as a little higher, 10 times higher, then within my beam I'm getting hogging moments.
Yeah, but then if it is hogging, then it should have been drawn below the horizontal line. That is only what I say. Because if at D, definitely it will be a hogging moment.
Yeah, you're right. You're right. Hmm. If it is sagging, then uh,
I think moment at A should have been clockwise. Then this bending moment diagram can be
Benjamin
justified.
diagram can be justified. But see, but I have one more question. Like if let us say if in this part, in DE part, there should be a sagging moment. Definitely, you're going to have a sagging moment here, and then somewhere this part it is going to go in this direction, and then it is going to come like this. You are able to understand, right? Like let us say if D is going to be my hogging moment, so you are giving a load something like this, and then it will not hog, right? It will not come upwards, right? At some point
No.
it should hog, and then it should come down, and then from there it has to lift up. See, and also there is one more point. The shear forces. Yeah, the shear forces. Yeah, the shear forces at this point is zero. You have this thing and this thing. Yeah, I think there is some. Maybe I think there is some. Yeah, there is some complication in this question. That's what I feel. But how do you define? See, for example, uh, how do you say whether it's a, hinge or it's a hinge or it's a roller? That is quite straightforward. You can see if it is a roller, right? There the moments at both the sides should be definitely of different signs, and also the shear forces at that maybe shear forces at the left and shear forces at the right may not be zero. So you have different slopes here. The one is something like this, and the one is in this direction. But at the hinge, you have a same slope. That means shear force
The
at left.
twin is lost.
Oh, oh, sorry. Yeah. Now you are able to see, right?
No, not yet.
Now,
No.
Anyways, actually, what I'm trying to say is the slope of bending moment diagram gives us the shear force, right? Shear force at that location. So what I'm trying to say is, if the shear force, if you want to find the shear force at that location, we need to just find out what is my uh, what do you call, what if at the hinge usually we'll have, hinge usually transfers only the shear force, right? So from the left side, whatever the shear force you get, the from the right side, it should has to be transferred through the hinge. So that is the reason why I think B was kept as a hinge. That is there's no problem with the B, but I think when it comes to A, I think that's a problem. Yeah, you're right. Okay. Yeah, maybe like you said, it it can be something like see, even if it is a clockwise, you're able to understand what I'm saying, right? Because in AD, what I mean, sorry, in the last part of the question, he's trying to say that uh, everything is hogging, right? In that in part DE. Hello.
Yeah,
Yeah, in part
yeah, I'm
CD.
listening.
Yeah, yeah. In part CD, I mean, sorry, DE. If you have a vertical force acting, you should have a sagging movement coming there, right? It cannot be a hogging movement in part, at least in DE, somewhere in between DE. Maybe possible. What about the second question? You are able to solve the second one?
Same,
Same.
same assignment.
Yeah, yeah, same assignment.
Yeah, I think.
See, it is again similar. See, if you see second,
Option C.
yeah, see second, see it is similar to the second one only, right? See in at C you have the hogging bending moment, which was shown accurately. Mm,
Yeah, they're same almost.
yeah, they're almost the same, but yeah, I think what I feel is that is a little ambiguous. That's what I feel. That question is a little ambiguous. There's, and I hope the such kind of questions will not be asked in the exam. Yeah,
Okay.
yeah.